Alright guys, let's go over your review. So if you guys want to watch this over or pause it or go back to spots that you're confused with, you can. So the first thing that I want to talk about is whether something represents a linear or nonlinear function. So when we're talking about graphs like in A or F, what you're looking for is points being connected by a straight line um, going from negative infinity to infinity, and for both the domain and range. So straight lines going in opposite directions is really what you're looking for. So A is not linear because it is curved, and it does not go off to from negative infinity to infinity. Um, when it comes to a table like B and D are, you're looking for rates of changes, so you actually have to find the slope at each one of the points. So you're just going to go down, and this one's adding 1 each time on the x, and then it's subtracting 8, subtracting 4, subtracting 2. And what I want you guys to check every single time is the change in y over change in x of both of them, and see if they're all the same. Every single one of them needs to be the same for it to be a line, because lines have a constant slope. So notice that the slopes are negative 8, negative 4, and negative 2, so that's nonlinear because the rate of change is not constant. When it comes to equations like C and E, you're looking for your variables to be raised to the first power. It does not have to be in slope-intercept form. It can be in standard form. It can be in point-slope form. It doesn't have to be in any of those forms. But you need two variables. Typically, they're x and y. It doesn't need to be that way. They need to be raised to the first power. The variables should not be multiplied. They should not be exponents. They should not be in the denominator. Those are all very important things. So x to the first power here, y to the first power here. You have two different variables. They're not being multiplied. This is actually standard form, and so this is a line. So it's linear. The variables. Now, it doesn't always have to be two variables. An x equals or a y equals equation also is a line. They're for vertical and horizontal lines, so just be careful. Again, for D, much like B, you're looking for that constant rate of change, so you have to figure out what's happening. So that's adding 3, adding 6, adding 2, subtracting 3, subtracting 6, subtracting 2. If I do the change in y over change in x, I get 3 over negative 3, which is negative 1. Change in y over change in x, negative 6 over 6, negative 1. Change in y over change in x, which is negative 2 over 2, which is negative 1. Notice that they don't look like they're all going to be linear just by the writing on the side of that table, but when you actually find the slope and simplify it, it is actually linear because the rate of changes are constant. E is another equation. The issue with this one is that you have an exponent as a variable as the exponent, which is not allowed for it to be linear. This is actually exponential, which is what the graph of A is. You will be learning about that in November. So this is nonlinear. The points are not connected by a straight line, which you would see if you did it, and the variable is the exponent, which is not allowed. And then finally, F is the graph, and typically you guys do pretty good with graphs, but if you notice the points are connected by a curve, not a straight line. Remember, the line does have to go off in opposite directions for it to be linear, not it could be two straight lines going in different directions. For it to be a line, it needs to be consistently going off negative infinity to infinity for both the domain and range. So f is not linear. Okay, so then we get into function notation. And some of you guys are really struggling with function notation. Typically you guys struggle with what is the input, what is the output, what is this saying. So we have to be careful here. Remember, when it's inside, it's your input, which means it goes in for x. So this is essentially saying x equals 3 in the function named f. So we plug that in there. Wherever we see an x, we plug in 3. Now, b is different, or b is the same as that, but d is different. D is the one that you guys often do wrong. So we solve this. This is 3 times 3. 3 times 3 is 9. So you get an answer of 4. G of 6 is saying let x be 6 in the function named g. So we're going to do that with that one. That means wherever we see an x, we are going to plug in 6. Half of 6 is 3, but it's negative, so we get 0. Letter C here is telling you to find f of -1, input -1 for x, and then add 2 to your final answer. So first you find f of -1. Make sure you're putting parentheses around the number as you substitute it in, because -1 times -1 in parentheses is different than having that negative outside of the parentheses, especially when you go to plug it in your calculator. Negative and a negative is a positive. Negative and a negative is a positive. So we get positive 2 plus 1. That's 4, but we can't forget to add that 2 at the end. So your final answer is going to be 6. So D. D is the one you guys all typically do wrong. Notice that the x value here is not substituted in for the number like in A and B. This is actually giving you the output, which is the outside number. So it's saying plug in the answer, which is -6, to that g of x. It's saying put it on the outside so that you can find x. So that's what we're going to do there. We're going to find x. We're going to solve. We're going to multiply by that reciprocal. So I get x equals 18. And then finally, E, which is what a lot of people did wrong on the quiz, is this one here. E is telling you guys to find g of 2 and f of -1 separately, and then take those two answers and subtract them. A lot of you guys did not subtract those two answers. So first we're going to find g of 2, which means this is replacing x, so that's saying let x be 2 in the g function. So we're going to do that. And I get 2 out, but I'm not done yet. I still have to plug in. And this says, in the f function, then the function named f, plug in -1 wherever you see an x. And remember to put parentheses around it. -1 times -1 is +1. -2 times -1 is +2. And we add 1, so that's 4. So we got our two answers, and then it says take those two answers and subtract them. So we do 2 minus 4, which is -2, and that is your answer. So that's the first page. So let's move on to the next page here. Here is a tricky question. It's trying to get you guys to understand the use of function notation and understanding what the input and output is. So if you remember, this is your x value, or your input, and this is your y value, or your output, which means this actually creates an ordered pair of 1, 10. What it's asking you to do is take that and write a function, write an equation where when you solve for x, your answer would be 1, or when you put in 1, your answer would be 10. So if you input 1, your answer would be 10. But you have to have x and y in the problem. So So just kind of play around with it. So if I think of this, if I want my final answer to be 10, if I substitute, if I have x here, if I substitute 1 in for x, 1 plus 9 would give me 10. Now that's not my only answer. There's so many different ways of doing this. If I wanted to do it as f of x, and if I do 2x, and it's saying plug in 1 for x, if I plug in 1 for x, I need to get 10. 2 times 1 is 2. If I add 8 to that, I'll get to 10. So those are not the only two answers. Those are just different things. Both of mine are linear. Because the variables are raised to the first power. And then the next one there. So that's just trying to extend it, understanding that this is your input, that's your output, and it actually creates an ordered pair on a graph. So it's saying if you plug in 1 for x, your output should be 10, or if you plug in 10 and solve it, then your input should be 1. Alrighty, so given the graph, answer the questions that follow. So you have this graph here. Notice that there's arrows, meaning it goes on forever. Notice, though, is this one linear? Think about that for a second there. Is this linear? The answer is no. Even though it's connected by straight lines, the lines don't go off in opposite direction forever. The domain and range is not negative infinity to infinity. This is not linear, so be very careful, because it does look linear. So it says, what is the domain and range of the function? If you remember talking in class, the domain relates to the x values. So if we're looking at the x values, we're saying left to right. If I look at this to the left, that arrow means it's going to go off forever and ever to the left, which is negative infinity. And we never include negative infinity, so we use a smooth bracket. And if it goes off the other direction, to the right, it looks like there's an arrow, so it's going to go off forever in that direction. So it's going to be negative infinity to infinity. The range has to deal with the y values, which is your up and down. So if I go down, I notice that they're never going to hit the graph down here. The first time I hit the graph is when y is 0. And 0 is included on the graph, so I use a hard bracket or a square bracket. And then if I continue up, it looks like those arrows mean it's going to go on forever, and up forever is to infinity and beyond. So we have, those are our range and domain. So then it asks you if the relation is a function. Remember, to determine if it's a function, it must pass the vertical line test, or every x value should map to exactly one y value. X's cannot repeat and be mapping to two different y values. Y's are allowed to. If we do the vertical line test, if you notice, I never hit the same point at a time, so it is a function. So this is a function. Then finally it says find f of 1. So you can just use the graph. We don't need an equation, and we got to figure out our scaling. We've been talking about scaling a lot. Looks like it's just counting by ones there. So I take that, and this is my input because it's inside. So I need to find my output. So I follow it out to get the y value. So I follow it up and over, and if I'm counting by singles there, that is 2. So f of 1 equals 2, or the ordered pair 1, 2 there. So we are going to get 2 there. Alrighty. The next one says, given the table, find the rate of change, graph it, and write the equation. I don't know that you guys actually have to write the equation anymore with this one. We'll be talking more about that one second quarter. But let's find the rate of change. All you need is 2 points for the rate of change. The rate of change is the change in y over the change in x, or y2 minus y1 over x2 minus x1. So I'm just going to choose these 2 points. These two are my ordered pairs. I'm going to call this y1, x1, x2, y2. So I do 6 minus 8 over 0 minus a negative 1. Subtracting a negative becomes a positive. So I have negative 2 over 1, which is just negative 2. If there are units, make sure you put the units on there, but there are not units on this problem, so you are good. We're just going to leave it as negative 2. So it says graph it. So to graph it, we are going to plot the points. Then I'm going to connect my point. Then I will connect my point. There. If you were to write the equation, although it doesn't ask for it, you just need the y-intercept, so you can do it in y equals mx plus b, and we'll talk more about this next week, but your b value is where it's your y-intercept, which is at 6, and your slope, we already found your m is -2, so that would be the equation if you were to write it. So it says find the inverse of the table provided in the table to the right. So we're actually going to find the inverse of this table. Remember we talked about inverses being the reflection over the line y equals x, and if you looked at the graph, you guys noticed that the ordered pairs were actually just being flipped. So an inverse is actually just switching the x and y values. So -1, 8 becomes 8, -1. And we're going to write y inverse with the little negative symbol because that's the way we write that. That means inverse. 0, 6, you switch that to 6, 0. 1, 4 is 4, 1. And 2, 2 stays the same because if you flip 2 and 2, it still stays the same. And it says graph the inverse on the same graph, so and label it. So we're going to call this y, so we know which one it is, and then we'll label the other one y inverse. So I plot it. And if you notice, we said this is the y inverse. We said it goes over the line y equals x, which is up 1 over 1. If you fold over that line, the lines will line up to each other. So if I want to take my piece of paper and fold over it, I could. And that is just the parent function as well, but it's also the line of symmetry on that. All right. These problems, some of you guys get them and some of you guys don't. The biggest thing is understanding the units of the x and the y, and understand this is an interval based on the domain, which means that they're only giving you x values. This is not an ordered pair. This is an x to an x. So it's saying read the graph from x is 1 to x is 2 and find that slope. So you can do it two ways. You can use the graph or you can create ordered pairs. So at 1, my ordered pair is 43. At 2, my ordered pair is 53. And then we can do the slope formula. So that's 10 over 1. And now we have to think about our units. It says x is days and y is degree Fahrenheit. So if you even just read the problem, it says the graph below shows the temperature in Fahrenheit in New York for 6 days. So the x is days, and we put x on the bottom, so that's days, and degrees Fahrenheit is top. So it's 10 degrees Fahrenheit per day. That's the rate of change. So then we do the same thing. This is an x to an x. So at 2, I followed up. My ordered pair is 53, and I'm going until I see 3, which is at 50. And we also talk about this in the sense that, again, remember x is days, which is your bottom, and your top is degrees Fahrenheit, which is your y. So I do 50 minus 53, 3 minus 2. Remember degrees Fahrenheit, days, do not forget those units. Use that graph. So that's -3 degrees Fahrenheit per day. So this is saying when x to x, when x is 3 to when x is 5. So we're actually going from here to here this time when we do that. So I have 3, 50 to 5, 59. So on day 3 it was 50 degrees Fahrenheit. On day 5 it was 59 degrees Fahrenheit. Do my slope formula. And we always simplify when it comes to real life events, contextual problems. You always use decimals. We don't usually use fractions when we're talking in context. So we get 4.5 degrees Fahrenheit per day. So then we do 4 to 5, which is just this little piece here. I'm going to show you how to do it on the graph. If you notice, we go up 2 to 59 over 1. So that's 2 over 1, so 2 degrees Fahrenheit per day. So you can always do it, count it on the graph. Some of them are not as easy to count on the graph because they have all these wonky decimals and then you can't do it. But it says compare the rate of change, which is the greatest and which is the least. The greatest is going to be the biggest absolute value number. You always take the absolute value. So we're looking at 10. The absolute value of negative 3 is 3, 4.5, and 2. So 10 is my biggest number. So we're going to say from 1 to 2, from day 1 to day 2. The temperature changed the most. Because 10 degrees Fahrenheit is the biggest rate of change. The least rate of change, and even though this is negative, that's not the smallest. Be careful, because we take the absolute value. 2 is actually smaller because the absolute value of negative 3 is 3. So from day 4 to 5, the temperature varied the least because it only changed by 2 degrees. Last question for this one asks us, what is the y-intercept and what does it mean in context? So the y-intercept is where it's crossing the y-axis, which is right here. So that's at 1, 43. And yes, we always write them as ordered pairs. Make sure you guys are doing that. So 1, 43, that's where it's crossing the y-axis. And this means on day 1, because the x is the number of days, the temperature, which is the y value is temperature, was 43 degrees Fahrenheit. So use those numbers when you're describing. Don't just write something down. Use the numbers to describe. Okay. Domain and range. A lot of you guys are struggling on when to use interval notation and when not to. Interval notation needs to be used whenever you can trace with your pencil. So you notice I can trace with my pencil. This I would not be able to trace with my pencil. It would just be points. So interval notation needs to be used for domain and range when you can trace with your pencil. Essentially when it's graphed or when it's an equation. The domain is your x values. So if I go to the right, go to the left, there's no graph over here and there never will be a graph over here. The first x value I hit is there. So if I count, that's 1, 2, 3, 4. So that's -4 and that's on my graph, so I include it. Then I go this way. The arrows mean it's going to go on forever. So going on forever to the right is infinity, and we never include infinity. Range is up and down. If I go down, that arrow means it's going to go on forever, so that means it's going to go forever down. Downwards is negative. It's going to go forever as well up. That's what that arrow means, which is positive infinity. So interval is when you can trace that pencil around there. Now, if it's not an interval, when it's just points plotted, you're just going to list out the numbers in set notation. That's what these squiggly lines mean. Set notation, we always go least to greatest. So we go -4, -3, 1, and 3. We don't have to repeat numbers when they repeat, so we're not going to repeat that 7 there. We have 2, 4, and 7. So you just list out the x and the y values for the domain and range. All right. Slope is your change in y over change in x, y2 minus y1 over x2 minus x1. So you just substitute those numbers in. You can label them to make it easier on you. So I have 3 minus a -5 over 5 minus 7. Minus a negative becomes a positive. So I actually have 8 over -2, which simplifies to -4. There are no units, so I just leave it as -4. I'll label those so I know which one is which. 5 minus a -2, 4 minus 4, So 2 minus negative becomes a positive. So that's 7 over 0. It is okay to have 0 on top. Your slope is just 0. It is not okay to have 0 on bottom. That's when your slope is undefined. If you guys remember us talking, a 0 slope is horizontal. A undefined slope is a vertical line. So 0 slope would be in a y equals, and a vertical would be an x equals, just as a reminder. So it's not okay to have 0 on the bottom. So we would say undefined slope. So it would be a vertical line. And you could plot those points and you could see that it's a vertical line, and that would mean it's undefined. There's different ways you can do this line that passes through the slope of 2/3 with 2r here. One of the things you can do is just use algebra, which might be confusing for some of you, but I'll still show you that, and then I'll show you another way. So we know m is equal to y2 minus y1 over x2 minus x1. So we're given the m, we're given a x1, missing a y1, but we're given an x2 and a y2, so we can plug those in. So 2/3 is my m, y2 is 3, minus r, 8 minus 2. And I subtract, you want to get rid of that denominator, so I multiply by 6 on both sides. So 6 times 2, so you multiply straight across is 12. 1 times 3 is 3. These simplify out, and that's 3 minus r. Then 12 divided by 3 is 4, so 3 minus r there. Subtract 3 on both sides. So I get 1 equals negative r, divide by negative 1, and r equals negative 1. So that's one way of doing it. Another way you can do this is to plot it on a coordinate plane. So if we plot this on a coordinate plane, what I would do is I would plot the point you know. So I would plot the point 8, 3. And I'm trying to get to the point when the value is 2. So I go down 2 over 3, but it needs to be a positive slope, so that doesn't work. Oh, made a mistake over here. 1 second. We have to go back here. So we go back here, and actually this is, oh no I didn't. So 12 over 3 is 4, minus 3 minus r. Okay, let's look at this here. R equals negative 1. So we're going to, when x is 2, which is over here, r should be negative 1. So we would go down 2, right 3, and that would be a positive slope, down 2, right 3. And notice, once we get there, we get to our point. So this would be 5, that would be 2, so that's 2, negative 1, and you can see that when x is 2, y is negative 1 in that problem. So that's another way you can do it, is just plotting the point. It's your choice how you want to do it. I can give you graph paper on the test if you want to do that. All right, next problem. Thomas is a handyman that helps out homeowners with small repairs. He charges $60 for each house call and $20 per hour for labor. Write an equation. So per hour is a rate, so that would be your rate, so that's 20x plus 60. We can write that as f of x equals 20x plus 60. Those are the same thing. Remember, y and x are the same. So how much would Thomas charge for a house call that took 5 hours? So let's know what x and f of x mean. X is the number of hours. Y equals the total cost. So the total cost there is your y. So if it's asking you if it takes 5 hours, that's your x value. So that's saying sub in 5 for that and get your answer out. So I have y equals 160. So it means that when Thomas works 5 hours, he makes $160. Since it's asking for how many hours, it's asking you to find the x. If he's charged $300, that's a total cost, which is our y. So we're going to plug in for y. So we find our x doing it that way. Divide by 20 on both sides. And I get x equals 12 hours. So that's what I would get with those problems there. When it's saying to graph the line with the most convenient method, it's saying look at your graph and say what kind of form is this in. So I would say this is slope-intercept form. So my slope is 2/3. My y-intercept is not there, so it's a 0, which means you start at the origin. The slope needs to be positive, so we go up 2, right 3. And if I connect those, that makes it positive, so I'm good. So I'm going to make another point, and then I'm going to connect those using a straight edge. This is in slope-intercept form. It's in y equals mx plus b again, so we're going to find the slope and the y-intercept. The slope is -2. It's in front of the x. The y-intercept is what's added or subtracted at the end, which is 4. So we always start at our y-intercept, which is on the y-axis. So I go up 4 on the y. And since it's negative, it's always over 1 if it doesn't have anything. We go down 2, right 1. If I were to connect those, it would make a downhill slope or a negative slope. So that is good. So I can connect those. Okay, so again, you start at the y-intercept, which in this case was 0. Then use the slope, which is rise over run. So I rise 2, run 3. Make sure it's going in the positive direction, which it is in this case. I start at the y-intercept, which is 4, on the y-axis, not the x. Go down 2, right 1. Make sure it's going to be negative like it says, and it will be. This is in standard form. In standard form, we usually find the intercepts. So if I want to find the x-intercept, which means I'm along the x-axis here. If I want to find the x-intercept, I'm along the x-axis, which means I haven't moved up or down anything. Y would equal 0. If I want to find the y-intercept, which means I'm on this up and down, this vertical axis here, means I haven't gone right or left any, so x would be 0. So we plug those in and find them. So I get x equals -4. Since x is -4 when y is 0, that's the ordered pair -4, 0. Then I let x be 0. Divide by 2. When x is 0, y is -2, so that's the ordered pair there. And I just plot those points. And you connect them. You can always switch something into slope-intercept form if that makes more sense to you, but this would be the most convenient method because it's already in that form. Y equals equations are horizontal. X equals is vertical. So you plot a point at -5. Since it's y equals, it needs to go through the y-axis. Since it needs to go through the y-axis, it's going to be a horizontal line. It needs to slice across that y-axis. Do not make it go up and down. So those are some forms. You also will need to graph from point slope form. So don't forget about that. That's not on here. Remember, that's y minus y1 equals m times x minus x1. Know that this is your slope, and x1 comma y1 is your point. Remember, we just use the opposite signs of x1 and y1 when we plot those points. So don't forget about point slope as well. Again, I'm going to use intercepts. I'm going to use intercepts when it comes to standard form, and this one is in standard form. And so is the next one, and so is the next two. So we're going to use those intercepts. You do not have to do it that way. You can always switch it to slope-intercept form. If it's the x-intercept, that means you haven't moved up or down any, so y would be 0. If you're on the y-axis, you haven't moved left or right any, so x would be 0. So that's the ordered pair. When x 2 and 2/3, y is 0. I'm writing it that way so it's easier to plot. I'm going to let x be 0. When x is 0, y is -4, so I'm going to plot those. And I'm going to connect those. And you have your graph. Again, you can put it in slope-intercept form if you want to. I prefer to do x and y intercepts. So we have 2x equals 7, divide by 2 to get that x-intercept, and I get 7 over 2, or 7, 3.5. So I get 3.5, comma 0. When I plug in 3.5, 0 comes out. Or if my output is 0, my input is 3.5. Divide by 5. So I get y equals 7 over 5, which is the same thing as 1 and 2/5. When you input 0, you get 1 and 2/5, and we plot those points. And then you disconnect them. So that's what I'm going to do on the next two. I'm not going to talk through those ones. I'm just going to do them real quick for you guys. Plot those points on the intercepts and you connect them. Again, I'm not going to go through this again. This is the 6th time I'm doing it, so. So when x is -3, that meant that y was 0, so that's my ordered pair. Y equals 9 over 6, or 6 goes in there 1.5 times. So when x is 0, y is 1.5. And you connect those points. So if you have questions on graphing, or if you want to just put it into slope-intercept form, you can. Just make sure you get the same line as I do. Alright, so let's answer some more word problems here, and then we'll talk about the inverses, and then we will be done. So the Smith family is on vacation. They travel 240 miles in the first 4 hours. They continue at the same pace. How far will they go in 3 hours? in the next 3 hours. So they go 240 miles in 4 hours. So we divide that, and that is a 60 miles per hour pace. So if they go 60 miles per hour, if they continue that pace over 3 hours, the hours will cancel out there. That's 120 miles. If their destination is 900 miles from home, how long will the entire trip take? So if we're just talking to get to the first place, and it's saying they're going at a consistent speed, so they're going 900 miles at 60 miles per hour. We can remember 60 miles in 1 hour. We can write that any way, and we want miles to cancel out. So it needs to be on the bottom, and that will give us the time on top. So I do 900 divided by 60 equals 15 hours. So one way equals 15 hours. So both ways equals 30 hours. Just double that. It's really important you guys do these unit conversions correctly. Make sure miles is on top and on bottom for it to cancel. Don't put the 60 on top even though you really want to, because it's 60 miles per hour. You can rewrite it the other way. That is okay. Alright, finally, writing inverses. Inverses are the reflection over the line y equals x, which means you just switch x and y. So all you have to do is switch your x and your y. All you have to do is switch your x and your y. It's a reflection over the line y equals x, so that's why that is the case. That means you just switch your x and y. I'm going to make these little inverses so we know that it's the inverse. Alright, so it's a little bit easier from tables. You can see it from a graph. If we're going to sketch the inverse, we have to find some of the points and plot those points. So this is negative 2, 2, negative 1. I have no clue what that is, so I don't want to use that point. 0, 3. That's 2, 4. Okay, so all you're going to do is take those points and switch them to get our new line. So f of x inverse is going to be these points here. I'm going to plot those. So you get the points and then you just switch them. You connect them, and they are the reflection over the line y equals x. So the line y equals x is this line here. So if you fold over on that line, the two lines would line up. So we're going to do the same thing for this next one. We just choose some points here. So that's 0, 5. If I choose 3, it should be enough. 2, 1. Negative 1, 7. So P inverse of x means just to write those the opposite way. Flipping your x and y. And then plot them. So I label that as P inverse of x. And then again, it's that reflection over the line y equals x. So if we were to fold over on the line y equals x, those would fall on top of each other. So that's what that is. Alright, so there's the review. If you want to re-watch it and play it, then you can. I will go over any questions you have. Just come in for help in the mornings if you need anything.